This is a solution to problem 3.2.14. It is similar to exercise 8 in homework 1. In this problem, we're given a random sample of 7 flight times. We're not going to study random sampling in this course. However, I do want to point out that the term random sample used in statistics is very different from random sample in everyday English. This is how it works in statistics. We've chosen one flight, a flight route, say from New York to Denver. We've recorded all the flight times during the week, maybe 85 flights. We then use a computer to choose 7 out of those 85. Random sample in statistics means no human is involved. If a human chooses those 7 flights, that is not a random sample. It has to be completely computerized. So that's a difference between statistics and regular everyday English. In statistics, a random sample means no human involvement. It's entirely done by computer. Let's go to some scratch paper to do the computation for range. What is the range? Well, the range in statistics has a very particular meaning. Like a lot of terms, in statistics, this is a term that has a more specific meaning than it does in regular English. The range in statistics, it's the largest number minus the smallest number in some set of data. Let's do a real simple example. Say our numbers were 3, 8, 1, 5, 2, and 2. The largest number obviously is 8. The smallest number obviously is 1. And so the range is 8 minus 1, or 7. So this has a very specific meaning. Let's go back to our data. I'm going to resize this down so that we can see both the scratch paper and the data. Out of these numbers, which one is the largest? Well, there's 283. Nothing is bigger than 283. So for these data, the largest value is 283. How about the smallest? There's a 271, 261, 258. 258 is the smallest. The range is when we subtract the 2. That's a 5 and a 2. So the range is 25. We could use technology, for example, StatCrunch or Excel, to calculate this, but that's really overkill. With 7 numbers, it's easy enough to scan them by eye to figure out the largest and smallest. So the range is 25. Let's put that in to my math lab. 25. Check our answer. Excellent. That was easy. The second part. calculate the sample standard deviation. There are actually two types of standard deviations. In this class, we're only going to do the sample standard deviation, so we're going to just call that the standard deviation. If you had taken Math 130, the course that uses the first half of this book, you would have also studied the other standard deviation. But in this class, we're only going to do the sample. Let me go to the scratch paper to draw a picture of what this is. So what is the sample standard deviation? So here's a number line, and we have various points. These are the data points in our data set. Whatever. We first calculate the mean, and let's say this is the mean. Of course, the mean is going to be someplace in the middle of all the data values. Then, for each data value, say this one, we look at the distance from the mean, and we square it. So we look at this data value, we look at this data value, we square this distance, we look at all, in this case, 8 data values. So for each data value, we square the distance, we add up the 8 numbers, add them up. So that's the total distance away, and then we divide by 7. Why do we average them with a 7 instead of 8? That's a more complicated theoretical statistics question, and we're not going to look at that at all. When we divide, this kind of is an average square distance. And that's called the variance. That's the statistical term for the average squared distance. The standard deviation is the square root of that, the square root of the variance. Because we took the square of the distance, taking the square root kind of makes sense because it undoes the square. So you can see this is a relatively complicated calculation, even for our 7 numbers. We first have to compute the mean, then we have to compute all the squared distances, then we have to add them up, divide by 7, that's the average, take the square root, that's the standard deviation. In cases like this, it makes a lot of sense to use software or technology. However, it is important that you understand what standard deviation measures. That's something that we're going to use almost every week from now on. We'll use software to do the calculation, but you absolutely need to understand that the standard deviation is a measurement of how far away we are from the mean. Let's do this calculation using both StatCrunch and Excel. So we go back to our original problem. Here are the 7 numbers these are our data. You'll gradually get used to in this class to clicking this double window here. That's the easiest way to import the data into StatCrunch or import the data into Excel. So if we click this, first we're going to do this in StatCrunch. So we open in StatCrunch, and let me move the window over so that we can see the values. Here is StatCrunch, and you can see we've entered the numbers, or MyMathLab has entered the numbers. That makes things much easier. It's very easy for us to make typos if we enter them manually. The standard deviation, that's under Stat, Summary Stats, and all the data are in a column. You may have used the same routine to calculate the mean and median. We choose the column. There's only one, the first variable, and compute. So here's the mean, the median, and here is the standard deviation. 8.426, blah, blah, blah. Type an integer or a decimal rounded to 1 decimal place. So let's round this to 1 decimal place. That would be 8.4, since the next digit is less than 5. So rounded to 1 decimal place, the standard deviation is 8.4. Let's type this in, 8.4. Check our answer, and that's correct. If we go back to our picture real quickly, what that means is the distance from the mean to the data values is roughly the standard deviation, the average distance. So since the standard deviation was 8.4 for this data set, the distance from the mean to the average point away is roughly 8.4. That's a typical distance from the mean of these data values. So remember, standard deviation is like an average distance away.